Today we want to discuss for the subtopic 3.6 Kirchhoff's Law. So actually we have Kirchhoff's first law and Kirchhoff's second law. Now look at the Kirchhoff's first law. The sum of current entering any junction in a circuit must equal the algebraic sum of the currents leaving that junction. So we can use the sum of current in equal to the sum of current out. So make sure at any junction. Now, this is a few examples to show how can we apply for the Kirchhoff's first law. Okay, so actually this is junction. This is junction. Alright. So I1 can be represented by the red color and arrow is out from junction because of this is junction. I2 can be represented by blue color is out from junction, but for the green color is I3. The direction is into the junction. So for this diagram, I1 and I2 is the current out from junction, the current out from the junction, and the I3 into the junction. So how can we write the Kirchhoff's law? The sum of I in equal to the sum of I out. So I in is I3, and then I out is I1 plus I2. So therefore, I1 plus I2 minus I3 equal to 0. Next. What about for the second diagram? Okay, look at the I1 out from junction, I2 out from junction, and also I3 out from junction. Therefore, this diagram disobey Kirchhoff's first law. Okay, next. What is Kirchhoff's second law? In any closed loop, the algebraic sum of EMF equal to the algebraic sum of the product, current, and resistance. So we can use the sum of EMF equal to the sum of product, current, and resistance. So make sure in any closed loop. Next, this is a few steps how to solve Kirchhoff's law equation. Step 1. Choose direction of loop. So you can choose either clockwise or anti-clockwise. Step 1. Step 2. Draw I1, I2 and I3 across each resistor. The resistors include external and internal resistors. Next step, write the equation for the first Kirchhoff law. So you need to write the sum of current in the junction into the junction equal to the sum of current out from junction at any junction. Next, identify the direction of EMF. Look at the two diagrams here. So this one refer positive terminal and this one is negative. This is negative, this is positive. Oh. So now, how to show the direction of EMF? Look at the positive terminal. So the direction must be from or out from the positive terminal. So this is EMF. This is positive, then out from the positive, this is direction of EMF. Next, write the equation for the second Kirchhoff law. The sum of EMF equal to the sum of product, current, and resistor. Notes: for EMF and product IR that have same direction, same direction with the loop, so the sign must positive. Meaning, if the direction of EMF same with the direction of loop, so become positive EMF. Same with the product IR. If the product of IR same direction with the direction of the loops, so become positive IR. This is the question related to the Kirchhoff law. Okay, step 1, we need to choose the direction of loops. So draw your loops. Now I just choose either you want clockwise or anti-clockwise. So this is clockwise. So you can label 2. Okay. So next step. This is the loop 2. So I want anti-clockwise. It will be okay if you want to choose the same direction as loop 1. Okay, next. Current. Okay, for this question given I1, the direction of I1, I2 and I3. So step 1, this is the junction. So the current must be in one direction. So this current, red current must I1. Only I1 passing through loop 1 here. Alright. So what about for the I2? Only I2, let's say this is the I2 given there. So this is direction of I2, this is also direction of I2. Okay, one direction, one wire. Okay. What about for the I3? So this is I3, right? Okay, this is junction. Alright. So this is I3. This is I3. Okay, this is I3. This is I3. Alright. Now, look at the direction of EMF. So what about EMF? So EMF, this is positive. So this is direction of first EMF. This is the positive, right? So the direction must from positive. So this is itu. Okay. So now look at the first law. First law, the sum of I in equal to the sum of I out at junction. Okay, I choose at junction A. So A. So which current into junction? Which current? The direction into junction. This is I1, this is I2. So I1 plus I2 equal to out from junction is I3. Therefore, I1 plus I2 minus I3 equal to 0. Equation 1. Okay, next, we want to apply the Kirchhoff's second law. The sum of EMF equal to the sum of product IR. Okay, now we want to focus loop 1. Okay, so where your loop 1? For the loop 1, so I use the highlighter to show all of you the yellow color is the yellow color is the loop 1. Okay. So loop 1, how many EMF? So how many EMF? Okay. So we have EMF 1 and also EMF 2. Right? So how many color of current? How many color of current? 2. The red color of current I1 and the blue color I2. How many resistor for loop 1? How many resistor for loop 1? So we have R1 2 ohm, R2 2 ohm here. Alright. So now look at the direction of EMF. So this is the direction of EMF. And then choose or compare with the nearest loop. So it's going upward. So this EMF is positive. What about for the E2? So E2, so the direction is upward, but the nearest loop the arrow downward. So different direction. So E2 is negative. Okay. So we just put here loop 1. The sum of EMF is positive 2 plus negative 1. Okay, this is the sum of EMF. Okay, next, refer to the product of IR. Product of IR. So now, this is the resistor 2 ohm. The current flow is I1. So check the direction of I1 compare with the nearest loop. Right and right. So this is positive. Positive I1 and 2 ohm R1. Okay. Plus. What about for this one? So R2 here. And then the current flow through R2 is I2. So I2 is upward. Right? But the nearest loop is downward. So different. So we can write negative I2 times with 4 ohm. Alright. So simplify 1 equal to 2 I1 minus 4 I2. Then just put here because of for loop 1 no I3, so just put 0 I3. So this become your second equation. So now refer to the loop 2. So loop 2, so we can see here, so consists of I3, okay, I3, R3, and then I3 here. Here, I2, EMF2, R2. Okay, loop, closed loop. So must be closed loop. Alright. So now refer to loop 2. Okay. Sum of EMF. So how many EMF for the loop 2? Only 1. Okay. Only 1 E2. Then compare with the nearest loop for the second loop. Okay, different. So this is arrow downward, but this is arrow upward. So negative. So the value is negative 1 volt. So because of only E2 here, so that's why for the EMF only 1 volt equal to sum of IR. So look at the loop 2. So how many color or how many current for loop 2? So we have green color I3 and also blue color I2. Okay, check. Check. For this resistance, Okay, 6 ohm, and the current flow through 6 ohm is I3, right? But now this I3 downward, but the nearest loop is upward. So different direction. So just put negative I3 6 ohm plus. What about for this resistor 2 ohm? So the current flow through R2 is blue color I2. So I2 upward. So choose the nearest loop is downward. So different direction. So put here negative I2 and then R2 is 4 ohm. Alright. So because of no red color or I1 for the loop 2. So that's why we just put plus 0 I1. Okay. So we get negative 1 equal to rearrange 0 I1 minus 4 I2 minus 6 I3. So this is the third equation. Okay, now just highlight. This is the equation 1. Okay, I write with the same unknown. Let's say I1 plus I2 minus I3 equal to 0. Okay, next, this is the second equation. Okay, so I just write 2I1. Okay, arrange with the same unknown. Minus 4I2 plus 0I3 equal to 1. Okay, next. This is the third equation. So I just put here 0I1 minus 4I2 minus 6I3 equal to negative 1. So now use your calculator to find the value of x, y, z. So x actually represent your I1 in ampere. Y actually I2 and Z actually I3. Done. Alright, so by using your scientific calculator, so we will get for the x equal to I1, the value of I1 is 0.32 ampere, I2 negative 0.09 ampere, and I3 equal to 0.23 ampere. So now, what is the meaning of negative sign here? So what is the meaning of negative sign here? So meaning in different direction. So, or let's see, look at your I2. I2 is here. So I2 refer to the original diagram is upward. So when you calculate I2, actually we get negative, right? So negative means the direction of I2 should be in different direction of original diagram. So let's say original diagram give you I2 upward, but actually I2 is going downward. Actually, so this is your I2. So what is the meaning of? What is the meaning of positive 0.32 ampere and positive 0.23 ampere? So meaning I1 in correct direction. Same with the I3. I3 is correct direction.